I just want to teach you about osmosis. Okay, today let's talk about osmosis. The visit theater at gmail.com. You can contact us, consult, comment. Yeah, we shall be seeing your comments and we shall reply soon. Okay, and David Seven Fancy Theater, the channel where you can access all science. Just don't forget to subscribe. Okay. Subscribe for more and better videos, like our videos, comment, and share to other students to also enjoy. Alright, so let's continue. Osmosis is just, you can define it as diffusion of water or any other solvent molecule through a semi-permeable membrane. It should be through a semi-permeable membrane. What am I meaning? This membrane is permeable to the solvent but can't be permeable to the solute, okay? And from a solution containing a lower concentration of solute towards the solution containing a higher concentration of solute. All right. So if we talk about osmosis, for example, if you have a sodium chloride solution and you place it on one side of the membrane, the semi-permeable membrane, you'll find that water on the other side, there is net movement of water which occurs from the pure water into sodium chloride. Okay, so if you put sodium chloride on one side, the other side you put water, you'll find that water will move from its side towards a solution of sodium chloride. Okay, so that is what I'm talking about in osmosis. Let's continue. This will define for osmosis and osmotic pressure, as you can see here, that I have this. If I put sodium chloride solution on one side and I put pure water on the other side, after some little time, you'll find that water levels are decreased and the solution of sodium chloride has risen a little higher because there's been a net movement of water from pure water towards a more concentrated solution. Okay, that is osmosis through a semi-permeable membrane. It allows solvent, no solute. Okay, and osmotic pressure is that very pressure we need. You see now the levels are equal. Okay, so the pressure which you can apply at the solution side to prevent movement of water through the semi-permeable membrane, that pressure which prevents osmosis is the pressure which we call osmotic pressure, just as you can see here. All right, so let's continue. So what is osmotic pressure? This is just the minimum pressure which, when applied on the side of higher solute concentration, will prevent osmosis. And if I refer to body fluids, it is the pressure exerted by solutes dissolved in water or other solvents. Okay, that pressure exerted by solutes dissolved in water or other solvents. And osmotic pressure exerted by the colloidal substances in the body, that one we shall call it colloidal osmotic pressure. And the colloidal osmotic pressure due to plasma colloids, call them proteins, is what we call oncotic pressure. All right, and this oncotic pressure depends on the number of molecules or ions dissolved in a solution rather than their size, type, or chemical composition. Just depends on the number of molecules, okay? Not their size, not their type, not their composition. As you can see, let's define now an osmol. There are a little bit of terminologies that we always have in when we are talking about osmosis. We shall talk about osmol. We shall talk about shall be talking about osmolarity, we shall be talking about osmolarity and other terminologies. So an osmol is just the unit used to place in place of the grams. And this is to express the concentration in terms of number of osmotically active particles in a given solution. Okay? And 1 osmol is equal to the molecular weight of a substance in grams divided by the number of freely moving particles liberated in the solution by each molecule. Note this very well. Is equal to the molecular weight of the substance in grams divided by the number of freely moving particles liberated in a solution by each molecule. Okay, that is an osmol. And 1 milliosmol will be just 1 over 1000 of an osmol. That is a milliosmol. All right, so it means 1000 milliosmols give you 1 osmol. Okay, and okay. So if you just have a molar concentration of glucose, it means this will contain 1 mole and exerts osmotic pressure of 1 atm, okay, on atmospheres. And if a molar concentration is of sodium chloride, this one contains 2 osmols. You can see this is 1, 2. Two ions are liberated in solution. Those are 2 osmols. That is 1 mole for sodium and 1 mole for chloride, okay, and exerts osmotic pressure of 2 atmospheres. Let's continue with other examples. If you just have a molar concentration of calcium chloride, this will contain 3 osmols, that is a mole of calcium and 2 moles of chloride ions, and thus exerts an atmospheric pressure of 3 atmospheres, osmotic pressure of 3 atmospheres. All right, so let's continue. Osmolarity. Osmolarity of a solution refers to the number of osmotically active particles, call them osmols per kilogram of solution. Okay, you see this? For osmolarity, where we have L, we also have osmolarity where we have R. So for this one of L, it's just number of osmols per kilogram of a solution, while osmolarity refers to the number of osmols per liter of solution. So per kilogram per liter, you can see that difference. R liter, L kilogram. Okay, that is it. Let's continue. Therefore, if you have understood this point, it means osmolarity is affected by the volume of the various solids in the solution and also by temperature, while osmolarity is not. This one, which is a per solution or per liter of solution, is affected by temperature and various solids in the solution, unlike osmolarity. That is an objective to ask, okay? And the osmotic pressure is determined by the osmolarity and not the osmolarity, okay? It's determined by this one of kilograms and not osmolarity. However, the quantitative differences between the osmolarity and osmolarity are just less than 1%. That is how they are different, just less than 1%. But in practice, osmolarity is more frequently used, the one of liters, because it is more easier to measure, like that of kilograms, okay? So what is the normal plasma osmolarity? Okay, the normal plasma osmolarity is around 290 milliosmoles per kilogram. That is for either extracellular fluid or intracellular fluid, you find it at around 290 millosmoles per kilogram. Each has 290, okay? So in the plasma, of the total 290, you'll find that 270 milliosmoles are contributed by sodium chloride and bicarbonate ions. The remaining 20 millosmoles is contributed by glucose and urea. All right, the remaining is contributed by glucose and urea. Okay, so let's continue. And because of large osmolarity, and hence lesser number of particles, the plasma proteins, those are like 70 grams per liter, only contribute to osmoles of the total 290 millosmoles per kilogram. Okay, because they are large, but their particles are few. We said it will depend on the number of particles in solution. So they only contribute 2 millosmoles out of the 290 millosmoles. Alright, so let's talk about tonicity. Tonicity, for example, we have hypertonic solution, we have isotonic solutions, we also have hypotonic solutions. So for example, when you look at this, 0.03% sodium chloride has osmolarity lower than that of plasma. We shall see this. But 0.03 sodium chloride is what? Is a hypotonic solution. 2% is hypertonic and 0.9% is hypotonic. Okay? It's isotonic. Isotonic, hypertonic, hypotonic. So if you look at this, when you have red blood cells here, you place them in a solution. The solution is isotonic. You see they are just the same size. When you place them in, they don't shrink, they don't swell. When you place them in B, which is hypertonic, the cells become smaller. They are shrinking. Those are red blood cells because the solution is hypertonic. Water is getting out of these cells into the surrounding solution. When you place them in a solution C, which is hypotonic, water will move from solution into red blood cells and they will burst. They swell, okay, and burst. So that is the difference. Right, so let's talk about tonicity of fluids. Tonicity, the word tonicity always refers to tonicity of a solution with respect to that of plasma. In clinical practice, okay, we compare it with that of plasma. That is around 290 milliosmoles per 290 milliosmoles. So in other words, it is the red blood cell membrane across which the tonicity is tested. We are using the red blood cell membrane as the semi-permeable membrane, okay? And thus, isotonic fluids are those which have osmolarity similar to that of plasma. I mean, 29 millosmoles. For example, 0.9% of sodium chloride, if you calculate it, the osmolarities are 290 millosmoles. And red blood cells will neither shrink nor swell in this solution. Hypertonic fluids are those with osmolarity higher than that of plasma, and red blood cells shrink in such solutions by losing water by osmosis. Hypotonic fluids are those with osmolarity lower than that of plasma, and red blood cells will swell up in hypotonic solutions by gaining water by osmosis. So let's talk about the applied aspects. How do you find applied aspects? There are a couple of them. For example, the total plasma osmolarity may increase in patients having severe dehydration. Okay, patients who have severe dehydration, you find that their total plasma osmolarity is higher than 290. Okay, and if there is increased blood glucose levels, for example, in patients with diabetes, also the plasma osmolarity will increase above 290. Also, if there is excessive intravenous administration of 5% glucose, this will decrease plasma osmolarity, leading to swelling of body tissues. Okay, when plasma osmolarity reduces, it will cause swelling of body tissues because water will be moving from plasma. If it is low, it means a lot of water will be moving from plasma into body tissues, okay, causing swelling of body tissues. Hyposmolarity can cause coma by causing the water to flow out of brain cells, and this is what we call hyposmolar coma. Okay, so if we are to continue, lastly, if you raise plasma levels of urea in patients, for example, with renal diseases, you'll find that there is hyperosmolarity. This hyposmolarity, when it goes higher and higher and higher, it might causes hyposmolar coma. Okay, thanks for watching my video. Don't forget to subscribe for more and better videos. Click the bell for every day we upload videos. Okay, thank you for